Hello there, my name is Professor Terry Moore and I'm the Director of the GNSS Research and Applications Centre of Excellence. Okay, so a question we often get asked is, what is GNSS? Well, GNSS stands for the Global Navigation Satellite Systems, and it's just a general term we use to refer to all the satellite navigation and positioning systems that there are currently in the world at the moment. The most well known of those is GPS, of course, and that's now very common in people's cars and increasingly in mobile phones. And GPS has got quite a long history. The development started back in the early 1970s, and the first satellites were actually launched in 1978. But in addition to GPS, there's also a Russian system called GLONASS, which has a similar sort of history, but went into quite serious decline in the early 1990s. But it's almost back up to full operational capability again now. And more recently, from about 2000 onwards, there is a European system called Galileo that's been in development, which again will be similar to GPS. And again, more recently, coming from China, a new system called COMPASS or BeiDou, which again will have similar capabilities to GPS. So how does GPS work? Well, fundamentally it's quite straightforward. It's all based on clocks. There are clocks on board the satellites and there are clocks on board the receivers, and whether that's receivers in your car or whether it's in a mobile phone or some other equipment. And we use those clocks to measure how long it takes signals to travel from the satellites down to the ground. Well, why do we do that? Well, what we're trying to do is work out the position of the receiver on the Earth or in an aircraft or where it happens to be. And to do that, we need to measure the distances from the satellites to the receiver. And we do that by timing these signals. So how long does it take the signal to come from the satellite and down to the receiver? If we know that, we can apply some physics, and that will allow us to work out the distances. The other bit of information we need to know is where the satellites are, but they continuously transmit that information, and so based on that information and the measurements, we can work out where we are, but also when we are. Because it's based on clocks, we actually have precise time as well as precise location coming out of GPS. GPS has actually been operational for a number of years now. It became operational in 1995, and since that time the number of satellites in orbit has not dropped below 24, which is the declared operational level. Currently there are 32 spacecraft in orbit, of which 31 are operational at the moment. So a question again we're often asked is, if there is GPS and GPS is now so commonplace and so prevalent, then why do we need to have the Russian system? Why do we need to have the European system? And why do we need to have the Chinese system? And the answer is quite simple. There are many reasons for financial and political reasons why these systems have been built. But a main reason from a user's point of view is we get added benefit by using them together. So a lot of work is now being done by the United Nations through the International Committee for GNSS, and they are leading the efforts internationally to get systems to work together, so we have what we call interoperability. And what that simply means is that a user can have a receiver and it won't just work with GPS. In the future it will work with GPS and Galileo and hopefully GLONASS and COMPASS sometime in the future. So many people are now familiar with GPS. We're seeing it in sat-nav in cars, we're seeing it in mobile phones and all sorts of new applications. We're seeing it in many books and films. But what are the other applications? Well, it's now changing the ways we live in many ways. So this is coming through transport. It's coming into obviously car transport, it's coming into rail transport, air transport and maritime transport. For example, in the air sector, the systems that are now being developed with GNSS are helping us to land aircraft in bad situations. And although we can do this in bad weather at the moment in certain airfields around the world, it allows us to do it at many more airfields, so therefore making aircraft more safe. And also it allows us effectively to get more aircraft into the air. So that's one sector, that's transport. If we look at the more precise measurements, then GPS is now used throughout the surveying and civil engineering sectors in terms of mapping, in terms of setting out, in terms of monitoring the movements of structures. And if we go a stage further than that, then GPS is also used to measure how the plates, the crust of the Earth is moving. And this is measuring rates at the same rate at which your fingernails grow. And we can measure that with GPS by measuring the motion of the plates on the Earth. In this country, we're particularly interested in vertical land movements. from settlement, from coal mining, but particularly in the southeast from settlement there and the potential impact of rising sea level and what that would mean to flood defences. There are obviously military applications, and there are many, many other applications now that are coming through sport and leisure and all sorts of different application sectors. And some of the work we're trying to do here is assisting the development of all those new applications. With all these increasing uses of GPS and on GNSS more generally in the future, it does mean we are becoming increasingly reliant on it though. We've all heard stories about people going the wrong way, being led by their sat-navs in their cars. Perhaps we won't get into that debate. But there are many, many other reliances we're now seeing, and a lot of those are coming through the unexpected uses of GPS, not just the uses in transport, but because GPS provides position and time, then we are all becoming incredibly reliant on GPS without even knowing it. Electrical power transmission, communications, the internet, banking are all reliant on very precise timing and synchronization of that time around the world. And increasingly that synchronization is coming from GPS. So if you take away GPS, we could potentially lose this very important critical infrastructure as communications, the internet, banking, power transmission are all reliant now on GPS to some extent. So as we move into the future and we see this increasing proliferation of different satellite navigation systems all hopefully working together, then it's going to allow us to use GPS and GNSS in more difficult environments. And what does that mean? It means in the centre of cities. It means potentially inside buildings. As we all get more used to using location as part of our everyday lives, the way we all use time now from a wristwatch, then we all need to have that location available everywhere and available seamlessly to the users. They don't want to know if they're changing systems, they just want that continuity, and that's where the future is going to go.